Hello everyone, I'm Kenshin. Welcome to History Talks. Please take a moment to subscribe, like, comment, and share. Also, don't forget to turn on the notification bell. Thank you. Today's historical discussion is about Mendeleev, who laid the foundation for the modern periodic table. Just like many of us, facing one of the most painful memories in chemistry, reciting the periodic table, with elements like helium, neon, argon, krypton, xenon, radon, it's a nightmare, isn't it? It seems impossible to apply it in exams, but for physicists, it's the culmination of a lifetime's work. Today, let's explore the history of the periodic table together. We all know that elements and atoms are the two cornerstones of modern chemical development. Since ancient Greek times, both elements and atoms have been defined as the smallest substances that make up all natural things. As they constitute the smallest units of everything, chemists dream of mastering them to truly understand the mysteries of the universe. In a previous episode, I mentioned the French chemist Lavoisier and the chemical revolution he initiated at the end of the 18th century, gradually unveiling the true elements to the world. As we enter the early 19th century, Dalton proposed atomic theory, making atomic weights essential data for chemical compounds. Between 1815 and 1816, the British chemist Prout observed that the atomic weights of various elements known at the time were integer multiples of the atomic weight of hydrogen. In 1829, the German chemist Dobereiner introduced the triads rule, dividing 30 of the known 53 elements into 3 groups. In 1862, French chemist Alexandre-Émile Béguin de Chancourtois, 1820–1886, inspired by Italian chemist Stanislao Canizzaro's paper on the periodic table read at the French Academy of Sciences in 1858, based his research on atomic weights. He elucidated that elements would arrange according to atomic weight, forming a telluric helix, because tellurium lies in the middle of this spiral pattern. In 1863, British chemist John Alexander Rayner Newlands, 1837–1898, began studying the periodicity of chemical elements. 2 years later, influenced by Dobereiner's law of triads, he arranged the known 61 elements in order of atomic weight and observed a similar property every seventh element, akin to musical octaves, coining it the law of octaves. However, in 1864, German chemist Julius Lothar Meyer, 1830–1895, completed the modern theories of chemistry, categorizing 28 elements into 6 families based on chemical bonds. But in 1870, he reordered the periodicity based on the relationship between elements and atomic weights. Finally, our focus turns to Dmitri Ivanovich Mendeleev, 1834–1907. On March 6, 1869, at the Russian Chemical Society in St. Petersburg, a paper on the relationship between elemental properties and atomic weights was presented, attributed to Mendeleev. Although he was absent due to illness, the paper was read by a colleague. That same year, Mendeleev condensed this paper into a 2-page German article titled, On the Relationship of the Properties of Elements to Their Atomic Weights, published in the Journal of Chemistry, including a periodic table. Mendeleev was born in a small town near Tobolsk, Siberia, bearing a surname from nearby landowners. His father was a teacher, and his mother hailed from a prosperous merchant family. As the youngest of 17 siblings, Mendeleev was raised as an Orthodox Christian. His mother encouraged him to patiently explore the truths of religion and science. His father lost his sight and profession when Mendeleev was young, leaving the family's financial burden on his mother's shoulders. In 1849, his mother brought him from Siberia to Moscow with hopes of entering Moscow University, but he was rejected. He later moved to St. Petersburg and enrolled in the main pedagogical institute in 1850. After graduating, he contracted tuberculosis and relocated to the Crimean Peninsula on the northern coast of the Black Sea, where he recovered over 2 years before returning to St. Petersburg. From 1859 to 1861, he researched capillary phenomena and the principles of spectroscope in Heidelberg. In 1861, he published a textbook titled Organic Chemistry, earning him the Demidov Prize from the St. Petersburg Academy of Sciences. In 1863, there were 56 known elements, with new ones discovered at approximately 1 per year. Other scientists had previously established the periodicity of elements. For example, John Newlands described the law of octaves in 1864, based on relative atomic weights, and confirmed the potential of new elements like germanium in 1865. This criticized concept was only acknowledged by the Chemical Society in 1887. In 1867, as a teacher, Mendeleev authored Principles of Chemistry, becoming an authoritative textbook of the time. Published in 2 volumes from 1868 to 1870, it was actually completed as Mendeleev prepared textbooks for his courses. While attempting to classify elements based on their chemical properties, he noticed a pattern leading to the hypothesis of the periodic table of elements. He claimed to have envisioned the complete arrangement of elements in a dream. "I saw a table in my dream, and all the elements were arranged as required." Upon awakening, he immediately recorded it on paper, feeling the need for only one correction. However, due to the lack of information, Mendeleev was unaware of the early work on the periodic table in the 1860s. He expanded upon this pattern by adding other elements and developing his extended version of the periodic table. As mentioned earlier, on March 6, 1869, he delivered a formal lecture titled "Dependence Between the Properties of Atomic Weights of Elements" to the Russian Chemical Society, describing elements and valences based on atomic weights, now known as relative atomic masses. Subsequently, Mendeleev published the entire known periodic table in a Russian journal and predicted several new elements to complete the table. A few months later, Mayer published a nearly identical table in a German journal, apparently preempting Mendeleev. By publishing the periodic table paper in a German journal, Mendeleev not only contributed to the dissemination of the concept but also helped spread his reputation. In 1859, he went to Heidelberg University, where he studied under Robert Bunsen, 1811–1899. The following year, he had the opportunity to attend the Karlsruhe Congress on Chemistry. He learned Avogadro's law at the meeting. Under the same temperature and pressure, equal volumes of any gas contain the same number of molecules. This greatly inspired his exploration of the periodic table. In addition, he proposed changes to some known elemental properties. Before this, uranium was generally considered to have a valence of 3 and an atomic weight of approximately 120. He realized that these values didn't fit his periodic table, so he doubled them to a valence of 6 and an atomic weight of 240, which is close to the modern value of 238. Was he mistaken? Certainly. He noted that the atomic weight of tellurium was higher than that of iodine, but still placed them in the correct order, erroneously predicting atomic weights that were recognized as incorrect at the time. Some scientists disputed his prediction of more elements, but when Ga, gallium, and Ge, germanium, were discovered in 1875 and 1886 respectively, he was proven correct, perfectly fitting the 2 missing spaces. Afterward, he received widespread accolades from scientific organizations across Europe, including the Davy Medal from the Royal Society in London in 1882. He was elected as a foreign member of the Royal Society, for MEMRS, in 1892 and appointed as director of the Bureau of Weights and Measures in 1893, holding the position until his death. He was elected as a member of the Royal Swedish Academy of Sciences in 1905. The following year, the Nobel Committee for Chemistry recommended to the Royal Swedish Academy of Sciences that the Nobel Prize in Chemistry for 1906 be awarded to Mendeleev in recognition of his contribution to the discovery of the periodic table. Although the Chemical Sciences section of the Royal Swedish Academy of Sciences supported this proposal, the Academy should have approved the committee's choice, as it did in almost all cases. However, at a full meeting of the Academy, dissenting Nobel Committee member Peter Classen proposed the candidacy of Henry Moissan. Additionally, Swant Arrhenius, who had significant influence in the Academy although not a member of the Nobel Committee for Chemistry, urged rejection of this recommendation, citing the antiquity of the periodic system and refusing to acknowledge a discovery in 1906. According to contemporary accounts, Arrhenius' motive for opposition was because Mendeleev criticized his dissociation theory, leading to resentment. After intense debate, the majority of the Academy chose Moissan by a single vote difference. Even a second nomination in 1907 failed due to Arrhenius' opposition. In addition to the periodic table, he also studied the composition of petroleum and aided in establishing Russia's first oil refinery, fully recognizing the importance of petroleum as a raw material for petrochemical products. He once said, "Burning petroleum as fuel is like lighting the stove with banknotes." In 1907, he passed away from the flu at the age of 72 in St. Petersburg. His last words to the doctor were, "Doctor, you have science, I have faith," possibly quoting Jules Verne. Apart from the periodic table, Russian chemist and science historian Lev Chugayev described him as a genius chemist, a first-rate physicist, a researcher with significant achievements in fluid dynamics, meteorology, geology, certain branches of chemical technology, such as explosives, petroleum, and fuels, as well as in other fields adjacent to chemistry and physics. He was a thorough expert in chemical and general industry, and an original thinker in the field of economics. Mendeleev was one of the founders of the Russian Chemical Society in 1869 and dedicated himself to the theory and practice of protectionist trade and agriculture. Such praise is indeed not excessive. However, the most interesting story beyond chemistry is about Russia's most famous vodka. The reason vodka is standardized at 40% can be attributed to Mendeleev. For example, in a Russian standard vodka advertisement, in 1894, the greatest scientist of all Russia, Dmitri Mendeleev, received an imperial decree to establish the quality standard for Russian vodka, and thus, Russian standard vodka was born. Others also cite phrases like, "the highest quality Russian vodka approved by Mendeleev-led Imperial Government Committee in 1894. But what is the truth? In fact, the 40% standard was introduced by the Russian government as early as 1843, when Mendeleev was only 9 years old. While Mendeleev did become the head of the St. Petersburg Bureau of Weights and Measures in 1892, which later evolved into a government agency, its responsibility was to standardize Russian trade measures and instruments, not to set any production quality standards. Furthermore, Mendeleev's doctoral thesis in 1865 was titled, "On the Combination of Alcohol and Water," but it only discussed alcohol concentrations exceeding 70%, and he never wrote any articles about vodka, clearly debunking the claim. In fact, in addition to the well-known periodic table published in the Journal of Chemistry, Mendeleev published at least 7 other periodic tables between 1868 and 1872. The modern periodic table we use today gradually took shape around 1950, with the discovery of the lanthanide and actinide series in the 4f and 5f electron orbits starting in 1940. However, numerous periodic tables were proposed and subsequently discarded during that time. As for the hidden secrets of the periodic table, Mendeleev couldn't accurately answer why chemical properties of elements correlate with atomic weight. With the discovery of more elements and the development of quantum mechanics, the mystery of the periodic table gradually became clearer. In 1897, British chemist Joseph John Thomson discovered electrons through cathode ray experiments, challenging the long-held notion of indivisible atoms. Later, American physicist Robert Millikan used precise oil drop experiments to measure the weight and charge of negative particles in atoms. In 1903, Ernest Rutherford found that radioactivity resulted from atomic decay. In 1911, Rutherford and German physicist Hans Geiger discovered that electrons orbit the atomic nucleus. In 1932, James Chadwick (1891–1970) discovered, through experiments, that besides positively charged protons, there is also a neutral particle called a neutron in the atomic nucleus. This discovery enhanced scientists' understanding of atomic structure and provided a more comprehensive basis for the periodic table. Modern scientists regard Dmitri Mendeleev's 1869 proposal of the periodic table not merely as a scientific achievement but as posing another new question: why do the properties of elements exhibit periodic relationships with atomic weight? The answer lies in electron configuration. When electron configuration can elucidate various properties of elements, understanding of elemental properties becomes clearer. However, this also demystifies the periodic table, as electron configuration is merely a quantity, the distribution of electrons in different orbits. Atomic weight comprises the neutrons and protons in the atomic nucleus. The relationship observed ultimately boils down to a correlation between quantities, losing the mystical allure previously associated with the perceived relationship between mass and quantity.